Hello and welcome to the GCSE Physics tutorial for topic P1 Energy. This tutorial covers part 1 changes in energy stores. Firstly, you need to know the different types of energy stores there are. The important principle of energy is that it cannot be created or destroyed. It can only be transferred, stored or dissipated, which means lost to the environment. The different energy stores are kinetic, so that's from something moving, thermal or heat, gravitational potential, so that's something that has the ability to fall, elastic potential, which is found in things like elastic bands, chemical, for example in a fuel like petrol, and then 3 other kinds of energy stores which aren't as common but you do need to know: magnetic, electrostatic and nuclear. It's important to remember that energy is transferred. This can be mechanically by a force, electrically by a charge, by heating or by radiation. So that can be as a wave like light or sound. One of the ways that you'll see energy transfers in the exams are as Sankey diagrams. This is a Sankey diagram shown here. So the size of the arrow and the directions of the arrow indicate the energy. For example, this is the energy transfer of a child going down a slide, and you can see at the start they've got 1,200 joules of energy, and then the child uses 800 joules to move, so that's the useful energy here. Wasted energy is indicated in the downward arrow. So you can see that more energy is used as kinetic rather than that's wasted. Here's an example of an energy transfer with a pirate ship. As you can see, energy is transferred from kinetic to gravitational. So it starts off here with the kinetic energy. As it starts to rise up here, it gets more gravitational energy and less kinetic. And then as it comes back down again, it converts it the other way. So when it's at the highest point, it has the most gravitational energy and the least kinetic energy. Here's another example of energy transfer. A boat, it will be powered on fuel, so that'd be chemical energy, which then is converted into kinetic energy to make the boat move. Another example is a kettle, which you would plug in, so that's electrical energy that's transferred into the thermal energy inside the water. Here's another example, a child at the top of a slide. So remember, conservation of energy means that energy is not made or destroyed, but instead it's transferred, or it can be wasted, it can go into the surroundings. And a lot of waste energy is as heat. Here's an example of a skydiver who has gravitational potential energy. Most of that will turn into kinetic energy as he's falling, but some of it will be dissipated as internal energy. You also need to know 3 calculations for this topic. You need to know how to calculate kinetic energy, which is half mv squared, which means half times mass times velocity squared. You need to know how to calculate gravitational energy, which is mgh, which is mass times the gravitational field strength, which is normally 10 newtons per kilogram, times by the height. And finally, elastic potential energy, which is half ke squared, which means half times the spring constant times by the extension squared. Here are some questions if you pause the tutorial and have a go at these. So first of all, what's the kinetic energy of this car? So first of all, recall the equation, half mv squared. So then do half times the mass, which is 2,000 kilograms, and then times by the velocity squared. So the velocity is 30. Don't forget to square that first, then times it by the mass and then halve it, otherwise the calculation will go wrong. And you should get 900,000 joules, so that the unit for energy is joules. Second question is to calculate the gravitational energy of a ball that's been dropped. So this time the mass, which is 5 kilograms, times by this g, which is gravitational field strength. Now, on Earth, that is 10 newtons per kilogram. So most often that's a number you would use, 10. And then times it by the height, which is 20 metres, you get 1,000 joules. Now watch out for these questions when sometimes the mass is in grams, so you have to convert it to kilograms, or the height might be in centimetres, so you'd have to convert it to metres, or the speed might be in a different unit, so you have to convert it into the correct units before applying the equation. Number 3, what's the energy transferred when a car is braking? Well, it'll be from the kinetic energy in the wheel to thermal energy because it will get hot when it creates friction. In summary, we've looked at changes in energy stores.